Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss the concept of velocity and acceleration for a fluid flow. And this concept is coming under the kinematics of fluid flow. Okay. And suppose let's consider a fluid which is flowing in all the directions. We know that basically the fluid used to flow in all directions, like 3-dimensionals, 2-dimensionals, even 1-dimensional also you can consider. So let's consider a fluid, and the fluid, suppose it is moving in x direction. Suppose this is x direction, and the fluid also can move in the y direction also, and this is suppose j direction. Or you can take this is x direction, and this is j direction, and this is y direction you can consider. So it can move like any directions it can be moved. So the fluid which is moving, suppose in the x direction, that we can consider with the fluid velocity is for this, let's suppose u, and the fluid which is moving in this direction, y direction, let's suppose this is consider u, you can consider v, and similarly you can consider this is suppose w. Okay, and similarly the acceleration for this also will be as usual like this. Okay, like acceleration ax, and this is acceleration az, and acceleration for this ay will be there. Okay, these are the directions of this fluid flow, like how it is moving in this x direction, y direction, and z direction, what is the velocity of this fluid, and what is the acceleration of the fluid. So to understand this concept, let start the derivation of this, like how we can calculate this velocity and acceleration for that. So first of all, let's consider the velocity. Okay, for this, the velocity is the, suppose let's consider this is the resultant velocity of any point of this fluid. So let's keep this is resultant velocity, okay, at any point of the this fluid flow. And as I told you that this u and v and w, these are the velocity, okay, in the x, y, z direction, in the x, y, and z direction. So let me keep it here, x, y, and z direction. So these are the velocities, and these are the directions, x, y, z directions. Okay, and here suppose the velocity component, we know that velocity means we know that this is the function of what? This is a function of space coordinates with respect to time. So this one velocity, if you want to write, then we can say that is dx with respect to dt. That means distance with respect to some time. This is to write in this way, dx by dt or dy by dt, something we can write. So velocity, we know that it is a function of space coordinates and time. So this velocity component we can write in terms of u, v, w. So how we can write that? U is a function of, it is a function of, we can write x, y, z, and function of time, because as I told you, velocity is a function of space coordinates with us and time. Similarly, we can write v equal to second function, suppose f2, with respect to again similarly x, y, z, and time t. And similarly the w, we can write this is the function of again f3, and we can write the function x, y, z, and t. Okay, and finally you can write the resultant velocity. The resultant velocity you can write, and this resultant velocity, or you can say the vector component, what we know the velocity. Okay, this is already I told you here. So v we can write in terms of u I cap plus v j cap and w I j k cap. So these are the vector notations, I j k cap. These are the vector notations are there. Okay, if you want to write the resultant velocity or magnitude of this velocity, also you can write in this way, root over of resultant velocity, that means u square plus v square plus we can write W square. Okay, and this is all about the velocities. Okay, how the fluid is flowing in all the directions, velocities. Similarly, if you want to consider the acceleration for this same fluid in all directions, then we can write, okay, let ax, ay and az, ax, ay and az are the acceleration in the same x direction, y direction and z direction respectively. You can write these are the accelerations in x, y and z directions. Okay, so now if we want to write this acceleration for formula, we can write acceleration. We know that it is defined the velocity with respect to time. What is the velocity of that flow with respect to time? Similarly, if you write ax, that means in the x direction, you can write here on behalf of velocity, we just can write, what is the velocity in the x direction, that means du by dt. Okay, so what I'll write here, let this acceleration ax, you can write, as I told you, du by dt, that means the velocity with respect to time in the x direction. Okay, so this is the formula we know previously. Okay, this is the acceleration formula and this is the velocity formula. We know this. Now this acceleration that du by dt, that also we can write in differential form, like del u by del x into, we can write del x by del t, plus similarly we can write in terms of, this is del u by x, here x term completed, now we will start y. Similarly again del y by del t, plus similarly del u by del w into del w by del t, plus we can write del u by del t. Okay, so these are the things actually that what I have written here. This is as per the chain rule. Okay, this is as per the chain rule. Actually, chain rule is nothing but this is the formula which expresses the derivatives. Okay, derivatives of any two components we can write. So this is another separate topic is there. That is only you can remember this is as per the chain rule concept. Okay, this is the concept of chain rule. Similarly, what I have written here in the for the ax, I can write for the ay also. So ay, what I can write, dy by again dt, the velocity in the y direction with respect to time. So similarly this also I can write in this way. So what here I'll mention here, okay, this is ay equal to dy by dt, correct. Now we know that velocity acceleration, what I have written here, ax equal to du by dt. So now what I'll do, du equal to, I can write dx by dt. Okay, so on behalf of this, what I'll write, on behalf of this, what I'll write, we know that u equal to dx by dt, correct. And similarly v equal to dy by dt, and similarly w equal to, we can write dz by dt. These are the velocity formulas what we know previously. Okay, now the same thing if you see in this equation, this is the equation what we got, correct. Let me make it highlight it. Okay, this is the equation what we got for the acceleration term. Now this value I can put in this dx by dt. Okay, this is dx by dt. This is actually del, all the things what I've written, that also you can consider here, same dx by dt and dy by dt and dw by dt. So what I'll write now, again the ax term we can write, okay, du by dt equal to what I've written here, del u with respect to del t into this del x by del t, or this one you can write del dx by dt. Okay, so that one I can write in terms of u. Similarly, same thing again, this one du by or del u by del y, this is x, del u by del x, okay, into y, plus similarly again del u by del z into w, okay, plus you can write this is del u by this is del t, okay. This is the equation what we can write. Now similarly in the same way we can write for ay also, acceleration in the y direction, so that is nothing but d dv, this is uv with respect to d del t. So similarly we can write del v by del x into u, similar terms, then del v on behalf of u only will keep the v value, del y into this is u, then we can write here it is a v not y, okay. Carefully we need to write these values, del v by del y into v again, and then we can write u into del v by del x plus v into this one also we can write, u terms gone. Now this is all these things will be v term only, okay, correct. Now similarly w into del v by del z, okay, uvw, and this is del v by del x, okay. Now similarly what we can write here, del here v by del t, okay. Similarly az you can write again dw by dt equal to, we can write again del w by del x into u again del w by del y into w, this is u, then v, sorry not w, uv. Now again w into del w divided by del z plus del w with respect to del t. So these are the equations what we got from this equation. Now this is the equation 1, suppose, okay, and we know that this is equation what we got. We know that for the steady flow, okay, if I write for the steady flow, we know that what, del p or sorry del v or derivative of v, dv by dt, sorry not dv, d rho, d for the steady flow the velocity with respect to, we can write that is 0, dv by dt equal to 0, okay. And this velocity is nothing but this is the resultant velocity for the steady flow, okay, velocity with respect to time. Now if this is the condition, then we can also write for the steady flow also, we can write du by dt and dv by dt and dw by dt all are going to be 0 here, correct, okay. Now the next step equation what we can write, so acceleration in the x direction, xyz direction, so you can write acceleration in x, y and z direction, we can write ax equal to, we know that du by dt, and that equal to, we can write u into del u by del x plus v del u by del y plus w del u by del z, okay. And similarly ay we can write y direction, acceleration y direction, del v by del t or dv by dt equal to, we can write again similarly here u into del v by del x, then v into del v by del y plus w into del v by del z, and similarly a w equal to xyz, az equal to dw by dt equal to, similarly we can write u del w by del x plus v del w by del y plus w del w by del z. So this is another one equation we can write. Okay, now this acceleration vector, what we can write? Acceleration vector we can write a equal to, as we know that axi plus similarly ayj plus we can write azk. Okay, and finally we can write acceleration, we can write the magnitude, if you write acceleration root over of this ax square and ay square plus az square. Okay, this is the acceleration. Now the same thing what we got here, here also some terms are there, different terms are there, that is like local acceleration and convective acceleration. So local acceleration and convective acceleration, let me go back to this previous one. So here just I'll mention that two things, two terms are there, local and convective. Local acceleration and convective acceleration. This is very simple only, I'll tell you. Let's go to the first equation. So where the equation 1, if you see this equation 1, let me give you a different color of this. Now in this equation, if you see all this equation 1 I have given, so all the terms are like same. Here this term, this term, this term, all are same, because same in the sense based on their directions it is given, correct? And this is one term, velocity with respect to time, different velocity with respect to time. Okay, so this is actually this term if you see, this is our local acceleration. Okay, these are the terms which is there, these are local accelerations, this one. So local acceleration is this, local acceleration. Okay, and these are the terms what is there, these are terms, this term and this term and this term, these are the convective acceleration. Okay, so this local acceleration and convective acceleration also we can define like the local expression we can be defined in the terms of the rate of increase of velocity with respect to time, the rate of increase of acceleration increase of velocity with respect to time at a given point of flow field, you can say. Okay, and convective experience, what we can say? Convective acceleration we can define that the change of velocity due to the position. This is change of position with respect to fluid particles in the fluid flow, we can consider that one. Okay, so these are there are two different terms are there, local acceleration and convective acceleration. So I hope you understand that is how to derive this velocity and acceleration for the kinematics of fluid. If you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.